Hi everybody, and welcome to our talk about making digital twins playable from UEFN to Unreal Engine. Really happy to be here today, glad that you can join us this afternoon.
Yeah, thank you so much for being here. And over the next about 40 minutes or so, we will share our journey on exploring how digital twins can go from static visualized models to interactive playable experiences. And we'll talk about what we've done so far, the challenges we've faced, and some thoughts about the future of playable places.
Yes, so we will talk about some general concepts when you're bringing cities into digital spaces and also get hands-on with the case study for today.
So with that, let's get started.
Yes, I'm Tomas. I'm the co-founder and creative technologist. I focus on game mechanics and interactivity, programming in verse and blueprints, audio, music production, visual effects, some data integration, and generative AI.
And my name is Linda, and I'm the other co-founder of Tomlin Studio. And my role is mainly creative direction within our team. And my background is within branding, digital strategy, storytelling, and I shape the concepts together with Thomas, of course, and the user experience and the overall design and look of the environments. And together we form Tomlin Studio, as in Tom and Lynn Studio. And we're a small immersive studio and a creative tech duo from Sweden, working in the intersection of creativity and technology. And we've been building stuff in UEFN since the beginning in 2023. And so far we launched 6 games. And we've done lots of other stuff for nearly 20 years now within the creative tech space. But today our focus will be on turning real places into playable places using UEFN, Unreal Engine, and other tools around these 2 platforms. So just to go into a little bit about the agenda today, we will start with an introduction, why we think digital twins should become playable at all. Then we'll go into a toolbox for capturing reality, things like 3D reconstruction, OpenStreetMap, and generative AI. From there, we'll dive into simulating reality and our case study, an introduction of how it all started, the goals of the project and the process, the pros and cons with UEFN, what worked, what didn't work, and some game concept exploration, and also look at our demo that we created in this project. And finally, we take a little short look into the future and talk about what we think might come next when it comes to playable places, and leave some time for questions and answers at the end. So, why playable digital twins? It comes down to shifting expectations. Some of us here remember the dial-up internet. Web 1.0 was mostly text and images, as you know. Then came Web 2.0 with social media and streaming and video everywhere. And now the next frontier is the spatial web, with immersive, interactive, and shared 3D worlds and spaces. And online social gaming platforms, such as Fortnite, Roblox, and Minecraft, have already shaped how Gen Z and Gen Alpha see the digital world today. For them, interactivity and being immersed isn't optional, it's the baseline. What they do in games today, they will expect in education, city planning, public engagement, and so on tomorrow. And at the same time as this is going on, cities all over the world are investing in creating digital twins. Most of these twins end up locked away in GIS systems and academic silos. And our question is simple. If these twins already exist, why not make them public, interactive, and playable? And this is where the power of play comes in. Play isn't just for kids. It's about lifelong learning and connections. Play is joyful, it's social and active. And it helps us think, grow, and feel together. And we all share the same planet, right? So why not combine the power of play with real world places and learn from that, while at the same time having fun and connecting with each other. And this is the foundation of our project that we call Playable Places, that we're going to talk about today.
And to be able to play with reality in the digital space, you first need to capture it. And there are a lot of different tools in the toolbox, like photogrammetry, Gaussian splatting, geodata like OpenStreetMap. We have photorealistic 3D tiles from Google, and also generative AI, etc. And all of these tools each have their own pros and cons, and if you get to know them, you can know how to combine them for the best results. So let's start with the classic, photogrammetry. It's like the OG of the bunch. Basically means you start with images or videos as an input, and the app calculates a point cloud to create a textured mesh. And the key concept here is something called structure for motion, which basically is trying to find common points in overlapping images to calculate how the camera has moved and thereby understand the 3D scene. We usually work with the reality scan. It was the app formerly known as reality capture. It's a very solid tool and it's widely used across industries. The main pros with photogrammetry is that you get an actual physical mesh that you can work with in your scene for shadows and lighting. And it's also easy to generate collisions from these meshes. It's a very established pipeline, so it works for large areas, and it also exports to a lot of common formats, so it's easy to find compatibility with other 3D applications. There are, of course, some cons. It struggles with motion blur and reflective surfaces. Also, transparency and fine details can often get distorted with photogrammetry. And then it can also take a lot of time to optimize after capture and do a lot of manual labor with small details that get distorted and so on. Since the lighting and shadows are baked into the photogrammetry, it's hard to relight it afterwards if you want to work with dynamic lighting. So that's a limitation. And also, since you're working with image textures, there's usually also resolution limitations when you put it in other applications. So it's a robust and powerful tool, but not always the most efficient way to go for every case, especially when you want to get close to the subjects. That's also usually where you run into some problems. There's another method that's still bleeding edge, but more and more becoming a standard part of the toolbox. It's called Gaussian splatting. And it takes the same input as photogrammetry, that is videos and images. And it also uses structure for motion to calculate the camera angles. But instead of representing the scene as 3D geometry, it creates these 3D ellipsoids called splats that they put out in the 3D space, like a point cloud of these shapes. And then it runs an optimization over and over, looking for all of the angles with photos, trying to match the best photoreal look. So these splats have a position, orientation, color, opacity, and size, more or less. And the big advantage here is the detail. So the splatting can handle things like leaves, hair, reflections. It can even do some view-dependent shading as well. But there are, of course, trade-offs. This doesn't create a real geometry. There's no physical geometry, so you don't have easy collisions or physics. And it's also limited when it comes to editing. You can remove splats from a scene, but you can't really deform these objects. And right now also this works in Unreal Engine, but it doesn't yet work in UEFN. So that's a big limitation. And in the project where we worked, we got access to some big Gaussian splats shot from the sky. But we wanted to see how would it look like if we captured an object that's smaller, a quite complicated object, a flower bouquet. It has a lot of semi-transparent surfaces, it has motion blur, and we want to see how could we make this look if we shot 400 images with a DSLR with some nice lighting. We had a softbox above it, and also we bounced two softboxes off the walls because you don't want to get direct lighting into the camera. And we did this like a test, comparing. You have to the left, you have the Gaussian Splat, and to the right, you have a Photogrammetry. So both are built on the same input images, but you can see the difference in the details and the color, these two methods. Another tool in the toolbox that's really powerful is Cesium, combined with Google Earth data and Unreal Engine. So what Cesium does is it streams the real world in 3D into your application. And it's built on a grid tile system, so it only loads what's visible to the player at that moment. And this is very useful for big games, simulations, XR applications, and also digital twins. And since there's an official Unreal Engine plugin, there's nice support with Unreal. And you can also, there are some pre-made data sets, but you can also add your own data sets. You can upload them to Cesium Ion, which is their cloud-based service. Right now that only works with meshes, but I think they're planning to integrate Gaussian splats as well in the future. And one of these pre-made data sets you have in Cesium is Google's photorealistic 3D tiles, which is basically Google Earth put into Unreal Engine. And this actually also includes collisions ready-made, so it's not just the visual parts, it's actual geometry. Right now, it covers about 1,900 cities, and if you're working with one of these cities, you have a really good base to build on. You don't have to start from scratch. It looks best from a distance. When you get close to it, you're going to see some limitations with artifacts. Cars don't really look great, and you have the normal limitations of photogrammetry with texture resolutions and so on.
Yes, and another tool in the toolbox is OSM data or OpenStreetMap, often referred to the Wikipedia of maps. And it's a global open data set built by contributors worldwide with building footprints and roads and parks and railways and points of interest of different kinds. And it's basically the backbone of how a city is structured. And the great thing about OSM is the speed and the accessibility, and that it's very lightweight. Because it's open data, anyone can use it. For us as developers, it's a quick way to generate a simple and pretty accurate geometry for layouts and collisions and prototyping playable environments. The downside is, of course, that it's very basic and there's no textures. There's missing details like roofs and interiors and sometimes incomplete height data. But as a lightweight and democratic starting point, it's a really powerful building block. And the last building block, or maybe not the last, but anyway, another one, is touch on is generative AI. And this space is, as you know, it's moving incredibly fast, and we're starting to see how it can support the playable places idea we have in many different ways. Right now, AI is really useful in early stages for pre-visualization, concept development, when we can quickly sketch out ideas and clean up messy capture before investing a lot of time in a project. It's also becoming a powerful tool for asset generation, whether that's textures, 3D objects, audio and music, or even code. You can also modify assets, optimize them, upscale textures, remove artifacts, or even change a scene's date, time, season, or even style. So imagine being able to see versions of your city or your place in summer, winter, or even in the year 2050 with just a click of a button. Finally, let's think about how AI can add life to these environments. If generative AI can make and optimize assets, agents and smart NPCs are what makes the world feel alive. And you can start simple with smart NPCs that just walk around and add some atmosphere. With conversational AI, powered by tools like Convey, or for instance, the upcoming Persona device in UEFN. You can even talk to a character, or why not a building or something else in an environment. In Unreal Engine, that goes further with learning agents, such as humans and crowds simulating city life, cars simulating traffic, and drones, for instance, delivering goods. The value here is that these AI-driven agents makes digital twins more dynamic and closer to how a real city actually behaves, and it adds life to scenes, which is very powerful for training and learning and also engagement, of course. So now we're going to dive into our case study. And with that background of capturing and generating reality in mind, let's look at what we've done with this case and how we actually try to adapt and implement a part of the city of Norrköping, which is a little bit south from Stockholm, their digital twin into UEFN and Fortnite. This is where our journey of making digital twins playable really began, and where we learned how challenging and exciting it can be to make a real place interactive. The origin story of this started in early 2024. We already knew that Norrköping had a digital twin, and as UEFN developers, we asked ourselves, what if we could bring it into Fortnite and UEFN? Could it work technically, and could it even be made public? And with some local support from the municipality, the science park, and the game cluster East Sweden Game, we kicked off small by mentoring 5 high school students in a 3-week summer project. And none of them had any game development experience, but they managed to build a simple prototype of Norrköping in UEFN, which you see here. They called it Revive. And the prototype was very basic, but it proved that the idea had potential. We couldn't, or they couldn't, I mean, we just mentored them, get the actual digital twin working at that stage. But it gave us a spark to apply for innovation funding and to dive deeper into, together with the municipality and the University of Linköping, to see how we could continue this project. And that's when the real journey of making digital twins playable began. So what were the goals of this project? First, a feasibility check. Could we actually bring a city's digital twin into Fortnite, both technically, but also at a reasonable cost, since we are working with either universities or cities, so the budget is important here. Second, to document the process so other municipalities, university, and developers could learn from it. And third, distribution and rights. If it worked, how could it be shared? Could it be shared through the marketplace fab.com, a project website, or some of the municipalities or universities' own channels? And what about license? Would it be a Creative Commons license for education only, or also commercial use? And then, of course, we needed some sort of a playable demo for stakeholders so they can see what was possible. And finally, the idea was to leave behind a template that others could continue to build upon for instance, game jams or student projects, and also future playable cities.
And the UEFN is a great tool. And one of the advantages is that you get a lot of functionality right out of the box, like multiplayer and multi-platform. This is something that is enabled by default. You don't have to worry about networking or compatibility. This just works. It's also connected to a truly global audience with millions of players already playing Fortnite. And for us as developers, UEFN is also great for rapid prototyping. And since it comes with URC, Unreal Revision Control, collaboration is really easy, and it also works for small teams. On top of that, there's a huge library of ready-made gameplay devices. These provide functionality like checkpoints, timers, scoring systems, and interaction mechanics. That's all the basics you need to quickly test out ideas. You also get access to Fortnite's characters and cosmetics, which makes it easier to create experiences that feel familiar to a lot of players. And with Verse as a new programming language, there's also more flexibility for custom logic than there was before. And finally, one of the most exciting things that we see also is the coming persona device, which gives you LLM-driven NPCs that you can actually talk to. And we're thinking about this could not just be talking to characters. This could in theory also be talking to having conversation with a building or a statue or any object in your world. So UEFN is not just a game tool anymore. It's an evolving into a platform for building interactive, social, and now AI-powered experiences as well. But of course, there's also limitation. Everything's not good. And when it comes to building these cities in Fortnite that are based on photogrammetry, Gaussian splatting, you have limitations like storage limit, for instance. You have 400 megabytes of storage, which might seem okay, but when you think about bringing city-scale meshes into Fortnite, it becomes a challenge. Also, there's a special limitation for UEFN that you can only have 64 materials on a mesh, which can also create challenges when working with cities. The textures limited to 2K. That's fine for a building, but it's more complicated when you're working with larger areas. And since Fortnite has to work on everything from a high-end PC to a mobile device, you always have to think about the lowest common denominator device to get everything working. It's not acceptable if it's just working for the high-end device. It has to work for all of the devices. And of course, Fortnite has been around for a few years, so there are some player expectations, and a lot of the players are still combat focused. So if you want to bring in new types of experiences, you have to think about how do you onboard these players and shift their expectations. Also, there's a wall around Fortnite, so there's no external APIs that you can't work with real-time data for driving simulations or visualizations in Niagara, for instance. There's no blueprint support, and currently there's no Gaussian splatting support either in UEFN. And on top of the technical limitations, we also had some constraints that are non-technical. So the municipality said no players shooting players and no realistic weapons. So that was a challenge as well for us to think about. When it came to data collection, we started working with the university. We quickly realized that there's not like one digital twin. There's a lot of different versions that sit in different places. There were more modern versions at the university, and also the municipality also had its own version. Some of these versions were photogrammetry meshes. We had both a more lo-fi older version that was big enough to build a game. It was lacking in detail, but it had a lot of coverage. And then we had a hi-fi mesh that was smaller in coverage, more details, but also more work to clean up. Like for instance, you have these windows here that would take a lot of manual work to clean up, and this would make it harder to work with this type of budget. We also had some Gaussian splats to test. We knew that this route was a long shot getting them into UEFN, but we really wanted to try to get this work, and it was like almost working, but not the whole way. So in the end, we had to abandon this idea of Gaussian splats in UEFN, at least for now. We might circle back to that in the future. And also, all of the data was captured from the air. It was plane data and drone data. And that's good for top-down gameplay from a bit of a distance, but it's not ideal for street-level experiences if you want to have players exploring closer to the ground. So right from the start, we had to make some choices based on this and see what was actually possible. So when it came down to choosing the version, we actually chose the more lo-fi mesh version. It wasn't the prettiest option, but it was the most practical choice. The main reason was feasibility. This would run on low-end devices, which is really important if you want to have accessibility and a broad reach, which we did. And beyond that, it also came down to the compromise between balancing quality, the coverage area, compatibility with UEFN, and also the sheer amount of work it would take to clean things up, because we wanted to find a process that could work for other cities as well. So in the end, the lo-fi mesh version gave us enough of the city to build a playable demo without making the project impossible within the scope. The next step was importing the digital twin into UEFN, and this was a very iterative process. There was not like one version and then we imported it. We needed to do this multiple versions to try out what was working and what wasn't. So there was a lot of importing, and in the end, the version we got working was in the SketchUp format. And in the first run, we imported it to Twinmotion, and then used Datasmith to get it into Unreal Engine, and then we migrated it into UEFN. So far, so good. But then we hit this limit with the 64 materials per mesh, so that didn't work. So we had to import it into Blender and slice it up. So we had this area, we sliced it up in 7 areas. So each area would not have more than 64 materials. And then we could export it as an FBX from Blender, and then we could put it into UEFN, and that was working. But of course, nothing is that easy. In this import process, all the materials and all the textures got mismatched. So we had to find them all, 164 materials and 164 textures, and manually reconnect them. That was a bit of a grind, but it worked. And in the end, we got the city up and running inside of UEFN, working nicely. When we had this version inside of Fortnite, it was time to adapt it to the Fortnite environment. That meant switching out a lot of low poly trees for the more recognizable Fortnite dynamic trees that were moving in the wind. We added dynamic water and waterfalls. We built in collisions so players could move around through the city properly. We also layered in some Fortnite devices to test out some mechanics and use post-process volumes to get a different look, and also added verse code for gameplay logic. The goal wasn't to make a finished game, but to show what was possible with these resources in this type of project. We also did some internal tests. Okay, we have this one version of the city. How would it look like if we would use generative AI to make different versions of it? So this was a test with a UV unwrapped texture from Arbetets Museum in Norrköping, going from the regular day capture into a night. And this is a test how it could possibly look, changing from daytime to evening to nighttime. And then it was time to try what kind of gameplay could fit in this environment, given our restrictions from the municipality. We tried a lot of racing games, both in vehicles like drones, helicopters, cars, you name it, and also grind rails, which is like a rail that the player can move along. And also tried some different item collection games. We also sketched up other ideas like different quests, player versus environments, fighting fantastical creatures, and also we were thinking about some early building mechanics, but this was during the spring, and the scene graph wasn't out yet, so it was kind of hard to build dynamic building games in Fortnite at that time. And on the more serious side, we also imagined perhaps crisis simulations, what would happen if a city would flood or a fire breaks out, or how could this be used in a playful way in urban planning or educational scenarios, where students, for instance, could test out ideas about climate, traffic, or design inside of their own city. Not everything of these ideas became a prototype, but the point was to explore what was possible. How could a digital twin become engaging? And what kinds of play, both fun and serious, make sense in this type of environment? And since all of the textures and all of the meshes were from drone and flight photos, we decided to focus on air-based mechanics. We tried some testing, some racing and collecting games, with flying with a drone, with a plane, helicopter, and the grind rails. And for the final demo that we showed, we focused on the drone. It's called a Falcon in Fortnite, so players can stand on the platform, fly with the drone, pick up items, and the player that first collects 5 different items could win, for instance. And then they could race for time and even build to extend the range of this drone. It was a straightforward setup, and it gave the stakeholders a clear hands-on feel of how digital twin can turn into something interactive and also playful. There are some things that are not at all possible right now in UEFN if you compare it to regular Unreal Engine. So there were some things that we missed that you could have done in Unreal Engine that was not possible. For instance, in Unreal Engine, you could target maybe only low-end devices or high-end devices. In UEFN, you have to make one size fit them all. We could have worked with larger projects. We could have used higher resolutions for textures like 4K or even 8K. And you can also create full open worlds in Unreal Engine that's more limited in UEFN. Also, we could have worked with external APIs to get data into Niagara, for instance, driving simulations. Google Earth, also not possible in UEFN, could have been done in Unreal Engine. It could also have more distribution options in Unreal Engine that's not possible in UEFN, like pixel streaming and even custom apps. Also in UEFN, you are locked into the Fortnite characters, but in Unreal Engine, you could have worked with MetaHuman characters or other services that you would prefer.
So far, we talked about the past and the present, and now we're just going to take a very quick peek into the future and the next frontiers. And Epic has announced that UEFN and Unreal Engine will merge into Unreal Engine 6, bringing together the speed and reach of UEFN with the openness and the power of Unreal. And we believe this could make the concept of playable places even more powerful. And just to wrap things up, what we believe are the future of playable places. Here are some key things that we hope you will take with you from today. First, digital twins don't have to be static. They can be opened up, made public, interactive, immersive, and playable. Second, there's no single way to do this. We've shown photogrammetry, Gaussian splatting, OSM data, Cesium, and now even generative AI. Each tool has its strengths, and the real power comes when you combine them. Third, the platform you choose matters. UEFN gives you speed, multiplayer, audience reach, while Unreal Engine gives you fidelity, freedom, and scale. And finally, play itself is a real driver here. Play isn't just for kids. It's something that we learn from and makes us engage and connect with each other. The future is about blending real places with playful social worlds. And that's what we call playable places. And we're excited to see what happens next. And to end this, before we open up for a Q&A, we will want to show you a demo video of the project that the stakeholder demo that we made. Thank you.